Hey guys, welcome back to AlgoYogi. We are doing binary search series, and our next medium level problem is successful pair of spells and potions. So let's do some magic, Harry Potter shit. Alright, so you are given two positive integer arrays, spells and potions of length n and m respectively, where spells I represents the strength of ith spell and potions j represents the strength of the jth potion. So you're also given integer success, and a spell and potion pair up and make basically a successful product if basically that product is at least of value success. We need to return integer array pairs of length n, where pairs I is the number of potions that will form a successful pair with ith spell. So basically we are pairing up all the basically we have the spells, and that's the size of the array we will return, and which we'll call it pairs, and that needs to have the number of basically successful products that particular spell can make with different potions. So let's understand that on paper. Okay, so these are our spells, and this is the success number, and these are our potions. What we really need to do is we want to find out these different pairs for each spells with different potions, so that the product of basically each of the spell, that particular spell is at least success, which is 7 here, all right, which is 7 over here. Now this does not qualify. How about, we are still doing it for 5, by the way, we are still doing it for 5. How about 5 into 2? So basically, rather than doing it here, I'm just gonna like show you what I really mean is just right here. So let's pair up 5 with 1. Is that a success? 5 into 1 is 5. No. How about 5 into 2? That makes it 10, so that's a success. How about 5 into 3? That's a success. How about 5 into 5 and 5 into 4? These are all success. Okay, so these are basically 4 different products that will basically be of value at least success. So when we are preparing this pairs, are basically result array, which will be of size n if spells are of size n and potions are of size m. Okay, so this will take, our 0th index will take 4 as a value, and then we are going to do the same thing, the same process for 1 as well. Okay, so we'll do that for 1 as well, and that will repeat basically 1 into 1, that's not a success. 1 into 2, not success, not success, not success. So none of these are success because all these products are basically lesser than 7, so this will be 0. And the same thing will repeat with 3, and we'll find out that the number of successful products that we can have are with 5 3s are 15, 4 3s are 12, and 3 3s are 9. So these two can make successful pair with 3, these 3 potions. Okay, so that will be 3, and this will be basically our answer, and that's what we will return. Okay, so the way that we just did, that is basically the brute force approach, isn't it? Because I'm going one by one each spell, and I am checking if it can make successful pair linearly with any of these, and if it does, then I basically put that number over here. So this is basically a linear search, and that will give us the time complexity of big of each m n with m. So that is basically n into m. So this is our time complexity. So now that is a brute force solution, and I'm saying it brute force because we do have a better solution, and that is, how about we find out how many portions can make a successful products with spells, and that we will do with binary search, and that will happen easily if we sort our portions, right? And let's go do that. Alrighty, so let's do that. So I think in this case it's already sorted, so we don't have to do that, but remember, it will not always be given to us as sorted. So what will really happen is, we have sorted our portions, and now our basic steps, basically having left and right pointers on our sorted portions. For each spell, I'm trying to find that minimum portion, minimum strength, or minimum powerful portion that will at least make basically a successful product, a successful pair. So if I find that out, and in a sorted portion, that I know everything after that, because they are all going to be of greater value than what I will find out, then I can just calculate that number of portions and just put that in my array. So for example, I'm still gonna have that pairs array. All right, and now what I'm doing is, I am checking for my first spells that what is that minimum powerful portion. If I multiply that with my spell, then that makes at least of value success, either equal or greater. So I've tried to find that middle, which will be 3, since these are the indexes 1 2 3 4, so 2 will be our mid is calculated, by the way, r plus l divided by 2, and we're taking integer division here. So is this a successful portion that will give me like an integer that is of value at least success when I'm multiplying it with by 5? And I think it does. 5 3s are 15. 15 is at least 7, greater than or equal to 7. So yes. So now what's going to happen is, I know that I just found this successful portion that makes the powerful portion enough to be included in my pairs. But I know that there might be another portion that could still make a powerful pair if I go towards left. I know everything towards right is gonna make, that's for sure, but I want to find out the minimum strength portion that will make basically successful product, by the way. So what I will do is, I'll move my right pointer to mid -1, so that next time I will calculate again my mid, and in this case it would be this. That does not make the successful pair, so I'll move my left pointer ahead, and in the end we will find out that 2 also makes a successful pair. So what I'll do, I'll keep storing that in a variable called like index, or dex. So I will keep storing that, and once I come out of this binary search, I will have an index, and I will assign that with the length of the portion, so that if I don't find that, then the way I will be calculating this total number of pairs would basically, if I don't find anything, then it will give me 0, and that we will basically need that, right? So okay, all right, so we will do that for each of the spells, and that will give us array. And I think we have understood it. We're gonna find out the middle, and we're trying to always seek that minimum portion that will whose product with spell will be at least success. So, and if this was smaller, then of course we would assign our right pointer to mid +1 or mid -1. That will be right. Okay, so this will give us the time complexity of this will be basically, if I'm sorting portion, if I'm sorting it and it's of size m, that was told to us, and it is of size n, so sorting will be basically big of m log m, plus for each portion we are doing basically a binary search on log m. So binary search is on the portion is of size m, and we are doing it for each spell. So let's do that, and this is definitely a better time complexity than m into n, isn't it? Yeah, it is. So by the way, like when you have like something like plus over here, then we just generally say like whatever the maximum is going to be out of these two will be basically our final time complexity. And for space complexity, we are not using anything, that will be constant. So let's switch our view to the code editor. Okay, looks pretty good. Okay, so whatever we have discussed, we're gonna have like our result array. I'll call it pairs. Then I am going to have a for loop for let's call it spell. We are doing it for each spell. So for spell in spells, for each spell, left will be, and I'm gonna have like as I said, I'm gonna have index to store the length. You know, I'm assigning this index. This will be, by the way, this will be our answer of how many portions can actually make a successful pair with this particular spell. So right now I'm saying all of them can make, but we are trying to find out that minimum portion that can actually make a successful pair. And in the end, we will calculate this by subtracting this from the length again. So I'll tell you like what I mean. So length of portions, length of portion -1, I think that would be it. Oh yeah, I mean this is just the length. And then we're going to have left and right pointers. So left would be basically starting with 0, and right would be length of spells. Okay, length of spells, no, length of portion, because I'm working with portions right now. Okay, and this will be a valid index. I need that. Then we, whatever, you know, what we do every single time in binary search is have our while loop to basically bring that input size to half in each operation when we are doing it, until we reach this condition when while left is lesser than or equal to right. Okay, then we're gonna find out middle. Middle would be r plus left plus right, divide integer division by 2. So if this success is greater than or equal to basically spell this particular spell into my current portion that I just found out in the middle, and I can access that using the index mid. Okay, if this is the thing, then I want to do basically two things. First, store that into my index, because I just found out a nice valid portion that actually makes a successful pair. So that could be my answer, but I'm still trying to find more, towards left. So what I'll do is index will store the answer. That will be basically this mid. And now I want to shift my right pointer to mid -1. And what else can I do here? I think that is it. Else I would just, now this condition did not satisfy, so I will just move my left pointer to mid +1 so that I can find that at least portion that can make a successful pair. So once I come out of this loop, I will have some value at index, and I will add that to my pairs dot append will be basically length of portions minus index, and that is because I'm trying to find, so I found basically this index, like let's say if I have a portion size of 5, then maybe I found some portion at second index. Second index would be 1. So I found that the value at second index, which is second index, no, that will be third value. So second index, like let's say third index, second value, third index, fourth value. No, oh my god, I'm so confused here. So second index, which is like of value 2, represents the third, and now that satisfied our condition. So I will subtract that basically 2 from my total length 5 minus 2. That will give me 3, including that 3 number that will go to my result. Okay, so I think this should work if I'm thinking it right. So, and then finally we will have a length of a spell, number of calculations done that was supposed to be in our answer, and I can just finally come out of this for loop and return pairs. So let's go over this again. So we are doing it for each spell. Initially my answer is just the length, it's not the answer, it's just, I'm just saying because I will be subtracting it. So if I didn't find any portion making a perfect successful pair, then I will subtract that same length from the length of portion, so that I get 0. That was the ask. If you don't find it, you put 0 there. So I'm gonna zoom out, and I think we are doing everything right here. So let's run it on the examples. Okay, so just two absolute basic thing we forgot is first we were supposed to sort the portions dot sort, and by the way, not success doesn't need to be greater, like the value that we are calculating needs to be greater than the success, and that's when we calculate the answer. Okay, that was absolutely stupid, but now it should work, all of it. Okay, so let's submit that, and successful. We're gonna write our time complexity. We talked about it in detail in the conceptual part, so that will be we are sorting portions which is of size m, and then we are for each spell which is of size n, we are doing a binary search on each portion which is of size m. All right, so this is perfect. And space complexity would be constant. All right, let's go to AlgoYogi and mark this solved. I'll see you guys later in the next video. Until then, bye bye.